Here's our augmented matrix for the system we were just looking at. What kinds of things can we do? Well, we want to try to convert this into something called upper triangular form. And here's a version of upper triangular form with just letters in place of numbers. The important thing here to note is that everything under this diagonal are zeros. Once that happens, we are in good shape and we'll be able to solve the system quite quickly from there. So what kinds of things can you do to a matrix without changing the answer to the problem that you're trying to do? One thing you can do is swap rows. So we could swap these rows and end up with 3, -2, 2, 1, 22, -4. We could swap rows. Well, what else could we do? We could take, and remember, we're trying to get zeros down here, and if we can, ones along the diagonal. And we have 1 here. That's kind of nice. What else could we do? We could replace row 1 with row 1 minus row 2. So we could say row 1 equals row 1 minus row 2. And that would give us, let's see, we're not changing row 2, but we are going to take row 1 and replace it with 1 minus 2. 3 minus 2 is 1. -2 minus 1 is -3. And 22 minus -4 is positive 26. I may look like it didn't help, but it did. We've got a 1 here and a 1 here on the diagonal, and that's a good idea. Okay? Now what we're going to do is, if we subtract 2 times R1 from R2 and replace it, let's see what happens. This is R2 is going to turn into R2 minus 2 R1s. Okay, let's see how that works. What will that give us? Okay. Row 1 isn't going to change. 1 minus 3, 26. Okay? So we're going to take row 2 minus 2R1. 2 minus 2 is 0. And 1 minus -6 is 7. And -4 minus 2 times 26 is going to end up being -56. Now the last thing we could do to this problem is, because remember these rows are really equations, we're getting equivalent equation sets, then we could divide both sides by 7, so we could take R2 and divide it by 7, and that would look like this. This looks like it's in upper triangular form. And if we translate this back into our equation system, what we have now is that y equals -8. 1y equals -8. Well, that's a solution, or part of a 1. In our next piece, we can do what's called back substitution. In that case, 1x minus 3 times -8 must equal 26. So we could solve that. This is x plus 24 equals 26. So x equals 2. We now have the solution to our system. The solution to our system is 2, -8. it might seem very complicated to you to see how to do these things, but you have to keep looking ahead to see how you want to make this diagonal, or at least the last number on the diagonal, equal to 1, like we did here. And once you've got that, 0, 1 equals to negative 8 in this case, you've got part of the solution, and you do back substitution. This is called Gaussian elimination. It's not the only way to work with matrices, but it's a great, great first step.